Hello, welcome to the continuation of our fundamentals of coding and algorithm. And in this session, we will explore different concepts concerning object-oriented programming. So what is object-oriented programming? So object-oriented programming is a programming paradigm based on the concept of objects, which can contain both datas, which we call attributes, and methods, or we call it functions. The key idea is to model real-world entities as software objects that have state and behavior. So what are key concepts in object-oriented programming? So in object-oriented paradigm, the most important key concept is a class. So what is a class? Class is a blueprint for creating objects, or we can say it class are blueprints from which objects are created. Right? So it defines a data structure by bundling data with method that works on that data, right? So we can call it like a map, blueprint from which we can create a real thing. That is what we call class. For instance, example for class is this one. So in this example, car is a class with attribute make, mode, and year. We say that a class can be bounded with data or attribute of that class and a function or method or what that class do or behavior of that class, right? So for instance, we can have a class called car. Class car or blueprint of this car always a car can have a model, right? A car can have a name, right? Those are attributes, yes? So a car also can have some behaviors, methods, or function like a starting engine, turning a wheel, and so forth, right? So that is what we call it a class. A second one is object. Object is an instance of a class. Is an instance of what? An instance of a class. Or we can see that object is that real thing that we can create from a class, right? So an instance of a class is object. Each object is independent with its own data and method. Unlike class, which is a blueprint from which you can create this real thing, object or these objects that we can create from a class can be independent, as each class can have, as each object can have its own data or attributes and its own function. Take example of a car, right? A car is a class or blueprint, right? But we can have a different object from it. Like we can have a car with a model BMW or Volkswagen or any kind, right? I think I'm very understood, right? You understood well. So for instance, here is my car is an object created from the car class. So my car is an object. We create it from what? From this car, which has Toyota Camry and the year of 2020. Also my car have what? Have a method called what? Start engine. The third thing is inheritance. When we talk about object-oriented paradigm, object-oriented programming, this kind of object that we create, or this class that at the end we get the object, right? This class can inherit one another. We can say that is a mechanism whereby a new class or a child class inherits some properties and behavior from an existing class, right? So if we talk about inheritance, we talk about child and a parent. A child is the one who inherits some characteristics from its parent. So that's what we call inheritance. So it's a mechanism from which a subclass inherits some kind of behaviors and the attributes from its superclass. So for instance, in this example that we will see, the dog class inherit from animal class and override the speak method. See this. So we have a class called the animal. This class called the animal have what? Have a name, right? So when we speak, right? When we speak is a functionality of this animal, right? We can have different animals like a dog animal, a cat animal. All of these animal can also speak. So we don't need to have many speak method. We can have a speak method from animal class, then we can inherit this kind of method from that class. That is what we call inheritance. So as you see here, a dog class inherited from what? From animal class. So a dog is a child and animal is a superclass or a parent class from which a dog inherit. So a dog can speak also, but what can he or she speak? A dog can speak, say woof, right? So my dog as an object, we say dog body, right? So if I print my dog.speak, this will print is that body say who, right? So that is what we call inheritance. Apart from inheritance, we have something called encapsulation. So encapsulation is a bundling of data, attribute, and method that operate on the data into a single unit or class. It also involves restricting access to some of the object component. So sometimes we need to have we need to have this attribute and a methods or behavior of this class, but this attribute and behavior, we want to restrict them to not be used by other class except from what class which is created that object, that method and attributes, right? So if we want something like that, then we can use encapsulation, right? So encapsulation, or through encapsulation, we can restrict access of some kind of our attributes and function to not be seen or to not be used by other classes. Why? Because these attributes are private. So in order to access this kind of attribute, you need to access them through the public methods, right? Yeah. So for instance, the dash balance attribute is a private and cannot be accessed directly after the class. So in Python, if you are creating a variable in a class, and that variable you put 2- below it, 2_ below before the name of that attribute considered as a private. So this dash balance make this attribute balance as private. So for instance, we have a class called the bank account. This class called the bank account have a balance attribute, right? So if I want to access this balance, see this balance is been initialized with 2_ or created with 2_. So this balance is private right now, right? So I can't access this balance by using my object. So I can't have object maybe called the CRDB and use that object directly to access this balance. So I can't say CRDB.balance. Why? Because I have a restriction. I can't access this type of attribute or this type of data, or we call it instance variable, without its method. So you need to have a method, public method, in which you can use to access this kind of private attribute. Apart from that, we have polymorphism. Polymorphism and the inheritance relate. Why? Because we can't have polymorphism if we don't have inheritance. But polymorphism is the ability to present the same interface for different underlying forms. So in object-oriented paradigm, we can typically have a polymorphism by using method overriding and method overloading. Are we there? Yes. So through method overriding, we can have a polymorphism. We call it runtime polymorphism. But through method overloading, we can have a compile time polymorphism. A method overriding is the phenomena whereby we can have different method from different interface, but the same method, but the implementation of this method can be different. So we can have same method with different implementation from different classes, but these classes should be inherited or should be inherited from the superclass. So through it, we can have runtime polymorphism, which is method overriding. But method overloading is the phenomena whereby we have different kind of method or same method, but always have different data types in its parameter or have different numbers of parameter in its what? In its method. So that's what we call method overloading. So here the make it fly function can handle different objects like bird and airplane that implement the fly method. Sure, casing polymorphism. See this. So we have a class called the bird, right? bird can fly, but also airplane can fly, right? So bird can fly and airplane can fly. So we can have a superclass with a method called the fly. So this superclass with the method fly, we can have other kind of subclasses which inherit from this superclass, which then will also inherit that method fly. But we can implement this method fly depending on different classes, right? So airplane can fly through engine, bird can fly in the sky, and so forth. So as you see, we have a def make it fly, which take an entity to fly. Then we have a bed, which is equal to bed, this object bed, plane object, which is a plane object. So make it fly. If I pass entity as a bed, it output what? It output flying in the sky. Why? Because a bird flying in the sky. If I put it a plane, then this one, which is airplane, it say that flying through engine. So that's what we call polymorphism. Let's see abstraction. So abstraction is a phenomena in which we always need to hide complex implementation details and showing only the essential features of the object. This is usually achieved through abstract classes or interface, right? Yeah, so abstraction is a phenomena in which we always hide the implementation, right? Or we hide some complex essential, hide some complex implementation details about a certain features. So we show you something, we show you the functionality, but we hide the implementation of that functionality, right? So you don't need to see the implementation, you just need the functionality. So that's what we call abstraction. So there are two ways of making abstraction. The first way is by using abstract classes or interface abstract classes, and second one is by using what? An interfaces. So for instance, we have a shape as a class, is an abstract class, and the areas a method must be implemented by any subclass, right? So if we have an abstract class, we can have an abstract method and we can have a normal method. But we have, if we have an interface classes, it means everything is abstract. Abstract classes are not 100% abstract, but interface classes are 100% interface. What does it mean? This means that if we have an abstract classes, inside that class we can have different kind of method. We can have abstract method and we can have normal methods. That's why it's not 100% abstract, right? So for instance, here we have a shape. A shape inherited from abstract base class ABC. As you see here, from ABC, import ABC and abstract method. So we have area. This area is annotated as an abstract method. Then we pass. Why? Because we want to implement this area in its subclasses. Then we have a class called the cycle, which take a shape as what? As which inherit a shape class, right? So shape is a superclass from which cycle can implement different method in it. So for instance, we can implement this area, right? So area is equal to 3.14 times radius, which we will put when we implement the shape times 2. So the moment we create objective for what? We create objective for this cycle right here, we can print cycle dot what? Cycle dot area, which will output what? Will output the values for our cycle. So that is abstract. So we have been given an activity. Explain the concept of inheritance in object-oriented paradigm, object-oriented programming with example. How does it promote code reuse and extendability? So take the moment by pausing the video and do this by yourself. Okay, so let's demonstrate different concepts about object-oriented programming. Say that in object-oriented programming, always have what we call class. So we need to have a class. So the syntax of declaring a class is class. So we declare any kind of a class. Maybe we have a class called the person, right? Then we can have a method, which is a special method called the init. This method or this special method is a constructor. So init method is this dash dash init dash dash. this one is a constructor. It is a special method which will always called the moment you create an object. So the moment you create an object, we call this what? We call this method, right? For instance, see something like this. I can say hello, right? So if I'm creating an object, let's say object called P, if I'm creating this method, it say what? It's print hello. Why it's print hello? It's print hello because I'm creating an object. I have hello in this constructor. Constructor is always created the moment you create an object, right? So take that in your mind. So init is a way to create a constructor. So we can say self.name is equal to what? Is equal to name. Self is this one, self. It is like a this keyword in other programming concept. It's like saying this class or this object. So this object name is equal to what? Is equal to name. So apart from this name is like an attribute, like. So apart from attribute, we say we can have different functions. So I can have a function called say hello, right? So this function can take up what? Can take up a self. Can take up what? A self or this. So as I can access my what? My inner instance variable. So I can say something like this. I can say print what? Print self.name. So this is a function or method of what? Of a class called a person. So a class called a person have this attribute name and have this method called what? Hello. So by then I can create an object. I say objects are independent. I can have different objects which implement the same class. So for instance, I have, let's say, person 1. This person 1 is equal to person, and this person called maybe Isa, right? So I can print, I can just call, because I already print, I can just call person 1 dot say what? Say hello, right? So I can say Isa says hello, right? So if I'm running this function, say Isa says what? Says hello. But also I can have person 2, which will be equal to person your name, right? So I can say person 2 say hello. So it say your name says what? Says hello. That's what we're saying. That's why we are saying that object can be independent. We can have different kind of objects which implement the same classes. Like we can have a single class or blueprint of a car class, but from that blueprint of a car class, we can implement, or we can have different objects of that what? Of that car, right? So that's what we call object and classes. So let's see encapsulation. So encapsulation, by demonstrating encapsulation, as I say, is the way of restricting access to our attributes, right? So I did say that if you want to create your object private, you will use to underscore like this, right? So something like this, print person.this underscore name. If I'm running this, it says that person object has no attribute name. Why? Because this object can't directly use the private attribute name. But if I'm removing this too, so if I'm running this, you see it say what? Isa. Why? Because I remove the 2 underscore which make our attribute private. So if attribute are private, means that we can't access this one directly, but we can access it by using a public method. So something like this, I can access it through what? Public method. So I can access it like this. So I can say something like this, return self dot name. So I can return something like this. So if I want to call this, so see I access this dot name here, this name, by using what? Method. So I can say something like this. I can say person1 dot say hello, right? So person1 dot say hello have to return what? Name plus say what? Say hello, right? So if I want to show this, I shouldn't use print. Let me use print. Let me use what? Let me use print. Print like this. So I just did concatenation. So if I'm running this, it says that Isa says what? Isa says hello. So that's what we're saying. Encapsulation is the way of restricting direct access of our private methods, private attributes directly. So we also see something called what? Inheritance, right? So inheritance is a way that we can inherit some characteristics from our parent. So I can have that, since I have already have a person, let me create another called what? Child. So this child inherit person. So child inherit person how? By passing a person in its parameter. So something like this make that child to what? To inherit a person class. So a child inherit a person class. So I can access this name here. I can access this name from what? This name from my person class here in my child class. Yeah, how I can see I can do something like this. I can do something like this. So I can do here and say print hello self.name. See, in my child class, I don't have a name, but I can access name. Why? Because I have a person whereby my child inherit what? Person, and the person has a name attribute. So if I'm calling this, if I'm saying child is equal to child, so if I'm saying that here is your name, we did inheritance. So if I'm calling this one, if I'm saying that child, let's say hello, and if I'm calling this one, it will print what? Hello, here is your name, we did inheritance. So we access name from what? From a person. Why? Because our child inherit person. So since our child inherit person, the way if we inherit from our superclass means that we can access any behavior or any attribute of our superclasses. So how can I demonstrate polymorphism? This is how I can demonstrate what we call polymorphism. So we have this say hello method here, right? Say hello method in our superclass, and we have the same say hello method in our child class, right? So these two methods, say hello method, this method in parent class and this method from child class are the same method, but we did implement different thing in here, right? So if I'm calling this one, okay, this one take no argument here. Let me remove this one because my child, I remove constructor, so I don't have to have a constructor. I can remove this one also and say this hello, this is from child, right? Something like this. So if I call this one, I have to run. So hello, this is from what? This is from child. Or I can say person is equal to what? Person. Then I can say person dot say hello. So here I can print, maybe I can print something like this. Hello from parent, right? So something like this. So let me do here this one. So let's say hello from parent. So that's what we call polymorphism. So we did the method of overriding from our polymorphism. So this marks the end of module 1. Please pass through attached document based on learning programming by using memory transfer language and links by yourself. If you have any question, check us. So in the next module, we will learn about algorithmic thinking. So thank you so much. See you in the next module.